We will collect Pokemon attack points using Python, and we will make sure that the code responses are actionable too. As you can see, this is the exact same input that I used in the Java-based JSON parsing exercise. I hope this video will help to shed some light on the differences and similarities between those two worlds. Let's dig in. We will develop a function called parse attacks, which gets a JSON object. I leave it as a stub for now, so just return none and write the testing code, which is going to be a single call to this function passing in the input JSON. And now we can run this code, and as you can see, we have the none as we expected. For JSON parsing, we will use the built-in JSON module, and if everything was as we expected, we could simply do a list comprehension, and that would look like JSON loads JS, and for each A in this loaded object, we just need to get the attack field. If everything was fine, this would work, but of course there are responses here that don't have an attack key. Now, if you would like to make sure this actually does something meaningful, I can change this index operator into a get function call, and then we can see the nones and the two actual responses that had an attack point. So this is the errors that we would like to handle better, and therefore the code will only ever get to this point in execution when everything actually has an attack field. So we can leave it as an index, and let's add the error handling. So I will need the attacks as a deserialized JSON object and traverse it multiple times to handle all the different possible errors. The first kind of error that we would like to handle is getting throttled. For that, I will write an isThrottled function that gets a response and returns if this means that the call was throttled. For now, I leave it as a stub and add the bigger control flow. We will use the built-in any function, which gets an iterator and returns true if any of the iterator's items is true. And when that will be the case, we will raise an exception, and this is just going to be a runtime error. The server is busy. Please try again later. And of course, the iterable for the any function call is going to be none other than if isThrottled A for A in attacks. So if any of the attacks means that we are throttled, just throw this error. Now, how do we implement the isThrottled function? Of course, we think we are going to be throttled if there is no attack field, and we can do that, check that, by getting the attack field and just putting not before that. And the other cases is when we get a 429 status code or a too many requests cause. Because we will need the error structure in these cases, let's parse that up front. A.get error, because we don't always have an error. Of course, there will be responses that are actually meaning success. And in order to be able to always dereference this structure, I will also add a default value of an empty dictionary. And now we can continue this logical expression. So if the status is 429 or the cause is too many requests, then we are throttled. Now we think we are ready with the throttle checking, so we can run the code and see that yes, the server is busy, please try again later. But of course, in the input we have also 400 statuses, which means that there was some problem with the query that the user can possibly fix, and they will fail regardless of the server being busy or not. So to be able to handle these correctable errors, we will need to collect them. Correctables will be just a list that we want to show the user when this happens. So if there's anything correctable in the query response, then we raise a different exception. It's going to be another error, but with a different text. Please fix your query. And just show the correctable errors. Now all is left is to build this list comprehension, which is going to be A for A in attacks, and we add a condition if the attack has a 400 status, and we of course check that by first getting the error. We also use the same trick as we used for the throttled to return a default dictionary so that we can do the next call, which is going to be getting the status. So if this is a 400 status, then this is a correctable error, but of course we have the whole response here and we really just want the cause. And at this point we already know that there's an error field, and we can just pop the cause with indexing. And now we can run the code and see, yes, please fix your query, no such Pokemon. This is it. Thank you very much for watching, and see you in the next one.